Yeah. Okay, so like I was explaining, let me write the sets again. A is 1, 2, and then B is 1, 2, 3, and 4. So the set difference, B minus A, okay, a lot of people are still not in. Yeah, so set difference B minus A is simply going to be what? 3, 3, and what? 3 and 4. Okay. So it is B less A. B less A. Okay. So in other words, you just subtract the set A from the set B to give you what? The set difference. Okay. Good. Now, if we should have the sets, let's say E, okay, E to be the universal set which contains 1, 2, 3, 4, and 5. And then we talk about A complement, either this notation or A complement. Then we are saying that elements which are not in A, okay, but are in the universal set, okay? So technically we'll write this. A complement are X, so that X belongs to what? Belongs to the universal set E, okay, but are not members. X are not members, are not elements of the set what? A. This is how we write it, okay? Good. And those elements will be what? 1 and 2 are in A, so they should not be members, okay? So those elements will be what? 3, 4, and 5. Okay. So that is for the complement of a set. Okay. So moving on, we go to, I think that's an example. So we have some laws here, which we must know, okay? Yeah, so laws, associative laws for both union and intersection law. We have commutative laws for the union, and then the intersection. We have distribution of the union and the intersection. We have the identity laws. A union, an empty set is A, whereas A intersection A is itself. Then we have the complement laws. A union A complement is E, that's the universal set, okay? Then we also have idempotent laws, okay? These laws are very, very important, especially when we go to digital electronics, where you need to operate Boolean functions, okay, into minimax and the maximum functions, okay, for implementation, okay? Yeah, if we need to reduce a very long, especially when we're using the Boolean functions or even the kernel maps, at times you have to use these operations to reduce to the minimum forms. Okay, so you have to learn them, especially the De Morgan's law, which tells us that the complement of A union B is equals to the complement of A intersection the complement of B. Okay, which also works for the intersection. So you take note of that. Make sure you learn these laws, please. Don't take them for granted, okay? Make sure you learn them. Yeah, then we also have the generalized union and the generalized intersection, okay? So for a generalized union, we are saying that's the combination of a number of sets, okay? Combination of unique elements, whereas the generalized intersection will be what? The combination of the intersecting elements or the common elements to all the various sets. So given the sets, let's say the set A1, okay, 1, 2, 3, 4, and 5, 6. And then we want the generalized union, which is usually written as union of SI, okay? That is just, you put the sets together like you can see here. So we have 1, 2, 3, 4, 5, and what? And 6. So the generalized union of this sets will be what? 1, 2, 3, 4, 5, and what? And 6. Okay. Good. Whilst our generalized intersection, okay, because there is no common element among these sets, the generalized intersection is going to be what? An empty set. Very well. Any questions so far? Any questions so far? Any questions so far? Okay. So we also have what we refer to as of a partition. Okay, we say that a partition of a set divides N into a set into what? Non-overlapping subsets. Okay, mutually exclusive what? Subsets. So by definition, we say that let S be a collection of non-empty subsets of X. S is said to be a partition of X if every element of X belongs to exactly one member of S, okay? So if you look at it carefully, oh, sorry, let me clear everything there. So this is the set X 1 to 8. And we are saying that for a partition to occur, we have one, let's say 2, okay. We have 3 here. We have 4. We have 5. We have 6 here. We have 7. And then we have 8. Okay. So if we can break this into subsets looking like this, that's 4 subsets. Okay, 4 mutually exclusive or non-overlapping subsets. Then we are talking about partitioning of the set X, okay? So S is a partition, okay? The set is a partition. Why? Because it has, first of all, divided the set X into non-overlapping what? Subsets. So the first subset is 1, 4, and 5. The next subset is what? 2, 6. The next subset is 3. And then the final subset is what? 7 and 8. Once that occurs, we say we have a partition of the set. Okay, then finally we go to the concept of Cartesian products. A Cartesian product is a set of ordered pairing. Okay, ordered pairs A, B. Okay, of A Cartesian what? B. So for example, if I have the set X as, if we have the set S as 1, 2, 3, and Y as AB, then the Cartesian product X, okay, Y, okay, is the pairing. So we are going to pair. So pairing just means you take the element here in X and pair with the first element in Y. So you get the pair 1 and A. Okay. Then when you are done, you do the next pairing, which will be 1 and B. Okay. Then next, you go to the next element. So it will be 2A, 2B. Okay. Then 3A, 3B. So we are just pairing them in that order. So that's a 2A, 2B, 3A, and 3B. On the other hand, if we are told to pair Y Cartesian X, okay, then in that case, Y comes first, okay? So you should pair, you should take the elements of Y first. So it's going to be A1. When you are pairing, it will be A1. Then you go A2, A3. Okay, so A1, A2 is here, A2, and then what? A3, okay? Then when you are done, you come to B1, that's a B1, B2, and B3, okay? That will give you the second pairing. That's Y Cartesian what? X. Very good. So on that note, we come to the conclusion of the topic of sets. But I should inform you that when it comes to this topic, especially in the writing of the set property, okay, nobody in this at this level will give you what do we call it? The set. I'm not going to give you the set B. Maybe the set B is a set X, so that X is an integer and X is less than 25. No, I may put B in the form X is such that X, okay, is a real number. It's a real number. And X squared plus 2X, okay, minus probably 1 is equal to 0, okay? So I'll put in the quadratic form. Then you will have to solve the quadratic equation to get the roots, okay, of the function. So you need to solve the quadratic equation to come out with the answers. Okay, that is what you'll be doing. So you have the questions in this form. And the key thing you have to take note of is that the defined set or the domain of X. Okay, you have to know what real numbers are, what integers are, what natural numbers are, what complex numbers are. Okay, so go and read on, further read on how to solve quadratic equations. Okay, and also read on complex numbers. Go and read on complex numbers so that you know, in case you meet a complex number or you meet a quadratic equation that involves a complex number, you will be able to solve it. Watch out for your assignment and your forums. Make sure you contribute, okay, on the platform. I'm not aware, course rep, have they created the Google class for this class already?
No, sir. They've not posted anything on the LEMSAS yet.
No, I mean Google class, because that's where we usually do the forum.
No, sir. No, sir.
Okay. So I'm sure they'll give us updates. Then I'll get back to you. Okay.
All right, sir.
Very well. But watch out for your assignment. I'll post an assignment. So watch out for it and submit your assignment duly. Okay.
Okay, sir.
Yeah. On that note, we come to a close of our first lecture. See you on Wednesday. Okay. And the post I gave, the link I gave will be for all our subsequent meetings. So when it's Monday, use the Monday link. And then when it's Wednesday, use the Wednesday invitation. That's all. Okay?
All right, sir.
Yeah. Okay. See you. Bye-bye.
All right, sir. Thank you, sir.
Good.
Thank you.